So the first thing we're going to do is, you're going to do that. I'm just going to sit back and relax, right? That's mean. You clean all of these up if needed. Then you find your intercepts and you rewrite, okay? And then tell yourself, is it solid or dashed? Where's the true region and where do I shade? For all three of them. I will try to always give you the inequalities like this so that you have the work underneath to do, or the space underneath to do your work, okay? If you recognize a special case, right, then you should be like, oh, this is less work. And so please try that. Don't graph yet unless you're absolutely certain. Okay. I'm going to do this. I'm going to go over it just to make sure you're on the right track. Most of you, what I'm seeing, it looks good, but I don't have like the time to like comb through everything. So just make sure you follow along, okay? So when I clean up, I mean, I want the x's and the y's on one side and the number on the other side, a constant. So I'll go 3x minus 4y is less than negative 12. I find my x and my y-intercept. I will copy this. 3x is equal to negative 12 divided by the 3. X should be negative 4. So negative 4, 0. Next, you've got negative 4y is less than negative 12. Sorry, I should just do the equal. Divide by negative 4. Y is equal to 3, 0, 3. Okay. Next, you have, you want to rewrite it. So I go to this one here, and I go negative 4y is less than negative 3x, negative 12, right? So I brought the 3x over, negative, divide everything by negative 4. You flip the sign because you're divided by negative, so that's 3 over 4x plus 3. Now I know that this is a dashed line, that the true region is above, and I will therefore shade below, okay? So there you have it. It shouldn't take you that long after you've done a few reps, right? This one, this is the tricky case. There's no constant. So this one is tricky. You got to use slope. Use slope to graph. And when I say no constant, I'm also kind of lying because the constant is 0. But what I mean, like there's no negative 12 or 3 or, right, a non-zero hanging around anywhere. So when I clean this up, I have 3x, right? 3x plus 4y is less than 0. I will find the x and the y-intercept. It ends up being 3x is equal to 0, so x is just 0. 4y is equal to 0, so y is just 0. This doesn't help us a whole lot. Mr. Dirksen, do I have to do this if I realize that it's a 0-0 situation? You don't have to do this. You can just go straight into rewriting mode. So watch what I'm going to do. I'm going to go 4y. That stays. The 3x comes over to the other side, subtracting. Then I divide both sides by 4. Y is less than 3/4 x. Remember that technically there is a plus 0 here. So my slope is negative 3 over 4, and b is 0. There we go. To graph this thing, that means I'm going to have to start at 0, and I'm going to drop 3 and run 4. Okay. Drop 3, run 4. There's your second point, folks. There's your second point, just like that, just using the slope. You have everything you need now. I'm going back to here, and I'm just going to say that this is a dashed line. True region is below. I will shade above. Got it? Here's my special case. This is also a special case. If there's only x, right? If there's only x and a number, it's going to be vertical. So at -4, 0. Okay, that's where this is going through. So no need to rewrite, no need to clean up, nothing like that. And so you end up with having to use this. X plus 4. Why do I do this? This is just for my calculator. This is for the calculator so that I can later find the points of intersection. Okay? What am I missing? I missed something there. I didn't tell myself, where's the true, this is a solid line. The true is where? To the right, correct? So I will shade to the left. There you have it. Let's highlight, I think I'm going to highlight all of those, like these lines here. This one, there's lots going on here, but ultimately that's where we want to go to get our information before we graph. Okay? You ready to graph now? Let's do it. So exciting, isn't it? Not really, I know. So this is a dashed line. I'm going to do this already. I used my slope for it. So there we go. And this line is y is less than -3/4x. Then the very first one was -4, 0, 0, 3. I got it right this time. The slope is positive, so I think I'm confident to say that this is going up like that. This is y is greater than 3/4x plus 3. And last but not least is the -4, this line right here. That is a solid line. That's x is greater than or equal to -4. That's what your graph should look like. Now shade, one at a time, okay? This first line here, I have to shade below. So I'm going to take this. Question. What happens if you shade everything? If you do this and everything is shaded, the entire thing is shaded, no white spots. There's no solution, yeah. You probably made a mistake. I'm just saying, I can't remember the last time I threw one of those in a test or anything like that. This one, it says shade above. So there we go. My radius still playing? It is. This one here, you have to shade to the right, to the left, sorry. So all of that is gone, right? So please just as small as you possibly can, but make sure you label that solution in some way, shape, or form. That is the solution region in there. And now the trickiest part, in my opinion, when you do the POIs for a lot of students is finding the intersection. So let's go ahead and do that together. Type in all of these equations into your calculator, okay? There we go. I'm going to use I already have this, so I'm going to change this to +4. My very first equation that I'm going to enter here is 3/4 x plus 3. Then I'm going to enter -3/4 x. So those are the three equations that I have. I hit graph. Perfect. Get to this point, okay? I'm going to focus in on the blue and the black. I know for you it's probably going to be a different color depending on which order you entered everything in. but I'm going to go second trace 5. I am on the blue, I hit enter. I'm going to jump to the black line, hit enter, enter. So this one is negative 2, 1.5, this one right here. So just label it. Then I'm going to focus on the red and the blue, the vertical and this line. Second trace 5. I am on the blue, right? So that's good. Enter. I am now on the red. Enter. Enter again. Negative 4, 0 is another one. And last but not least, second trace 5. I now want between the black and the red. So I'm going to jump to the black line, jump to the red line using up and down arrows, and it's negative 4, 3. You cannot see that, I think, but there you go, negative 4, 3. And I use second trace intersect. How are we doing? Is it okay? Doable? I hope it's fun. Let's make it fun. Anyways, now you're stretching it, right? Mr. Riggs, now you're stretching it. Your definition of fun and my definition of fun, very different. All right, let's see if this is a solution to the system. Algebraically, right? So we type in, substitute in. This is negative 9 is less than, this is 8 minus 12. That would be negative, sorry, 4 minus 12. That would be negative 8. Is this true? Yeah, last time I checked, that's true. Next is the 4y is less than negative 3x. So I always use the original inequalities for this. 4 times 1 less than negative 3 times negative 3. So you got to watch out. The x and the y are flipped. So, right, this is x goes in there. This is y goes in there. 4 is less than 9. True. Keep checking. Okay. That last inequality is greater than or equal to negative 4. You plug in x. Is this true? We're good. Is this true? Therefore, is a solution. Okay, so if everything checks out, if all of them are true when you plug in that point, you are good to go. All right. We're going to go to 36. So your homework will be, I'm going to say 36, 37. And guess what? I will post the answer keys, but let's say you don't like to look at the answer key. Look at the bottom here. It has the points of intersection down here. So technically, if you did this right, you should get these points of intersections, right? So 36, 37.